Download this code from codegive.com, link in the description below. Migrating from RAID 5 to RAID 6 without data loss, a comprehensive guide. Disclaimer ** While this guide outlines the process of migrating from RAID 5 to RAID 6 without data loss, it's a complex operation. Data loss is always possible when making changes to RAID configurations. A complete backup is absolutely mandatory before attempting this migration. If you aren't comfortable with command line tools, RAID management, and the potential for disaster, consider hiring a professional. Why migrate from RAID 5 to RAID 6? RAID 5 offers a good balance between storage efficiency and redundancy. It uses parity information distributed across all drives in the array to provide fault tolerance, allowing the array to function correctly even if one drive fails. However, with the increasing size of hard drives, the rebuild time after a drive failure in RAID 5 has become a significant concern. During the rebuild, the array is vulnerable to data loss if another drive fails. RAID 6 addresses this vulnerability by adding a second parity stripe. This allows the array to tolerate the failure of two drives simultaneously, significantly increasing data redundancy and reducing the risk of data loss, especially during rebuilds. While RAID 6 has a lower storage efficiency than RAID 5, more space dedicated to parity, the increased data security is often worth the trade-off. Prerequisites ***. Backup, ***. This is the most critical step. Create a full backup of all data on your RAID 5 array. Verify the backup's integrity. Consider using multiple backup methods, example cloud, external hard drive. Sufficient free space ** You will likely need free space on your existing drives for the rebuild process. The amount depends on your RAID controller and how it handles the parity calculations. Ensure you have enough free space to facilitate the migration. A good rule of thumb is to have at least the size of one drive available. Hardware RAID controller or software RAID. MDADM. This guide will primarily focus on using MDADM, Multiple Devices Admin, the standard software RAID tool for Linux. The principles apply to hardware RAID controllers, but the specific commands and interfaces will vary. Consult your hardware RAID controller's documentation. Root or sudo access *. You need root privileges, or the ability to use sudo, to execute the necessary commands. Stable system *. Ensure your system is stable and unlikely to experience power outages or hardware failures during the migration process. Use a UPS, uninterruptible power supply, if possible. Patience *. The migration process can take a significant amount of time, depending on the size of your array and the speed of your drives. Avoid interrupting the process. Understanding of RAID concepts *. Familiarize yourself with basic RAID concepts, including RAID levels, parity, rebuilds, and the function of MDADM. The general process, MDADM example. The general process involves 1. Checking the RAID array status *. Verifying the current status of the RAID 5 array. 2. Stopping the RAID array *. Bringing the array offline gracefully to prevent data corruption. 3. Changing the RAID level *. Modifying the RAID level metadata to RAID 6. 4. Adding a drive, if needed. If your RAID controller requires an additional physical drive for RAID 6, you will need to add one. Software RAID, like MDADM, can create a degraded RAID 6 array with the same number of drives as your original RAID 5. 5. Restarting the RAID array *. Bringing the array back online. 6. Reshaping the array *. This is the crucial step where the parity information is recalculated and the array is converted to RAID 6. This will take a long time. 7. Monitoring the reshape process *. Keeping a close watch on the progress of the reshape to ensure no errors occur. 8. Verifying data integrity ** after the reshape is complete, thoroughly verify the data integrity. Detailed steps with code examples, mdadm. 1. Checking the RAID array status ***. First, identify your RAID array. Common names are /dev/md0, /dev/md1, etc. Use cat/proc/mstat to find your array and its components. Example output. In this example, /dev/md0 is the RAID 5 array. The drives involved are /dev/sda1, /dev/sdb1, /dev/sdc1, and /dev/sdd1. U indicates all drives are active and synchronized. Next, get more detailed information about the array. This will show you *RAID level * confirm it's RAID 5. * chunk size * the size of the data blocks. Note this down, you might need it later. *array size * the total size of the array. *state * should be clean or active. If it's in a degraded state, example 1 drive failed, do not proceed until you've replaced the failed drive and rebuilt the array. Number of devices * the number of drives in the array. Active devices * the number of active drives. Working devices * the number of drives participating in the RAID array. These should all match the number of devices value. UUID * the universally unique identifier of the array. Important for assembling it later. 2. Stopping the RAID array ***. Unmount the file system on the RAID array first. Find the mount point using DFH. Example output. In this example, the RAID array /dev/md0 is mounted at /data. Unmount the file system. Now, stop the RAID array. Verify that the array has been stopped using cat/proc/mstat again. It should no longer list /dev/md0. 3. Changing the RAID level ***. This is where you tell mdadm to change the RAID level to RAID 6. This does not immediately change the data layout, it only modifies the RAID array's metadata. 4. Adding a drive, if necessary, and updating the array size ***. With mdadm, you often don't need to physically add a drive to migrate from RAID 5 to RAID 6. Mdadm can create a degraded RAID 6 array with the same number of drives as the original RAID 5. This is what this example assumes. The reshape process then adds the second parity. If you need to add a physical drive, consult your hardware RAID controller documentation or mdadm documentation for how to add it. After adding the drive, you might need to update the array size. This command will tell mdadm to use the maximum available space on the drives after the new drive has been added and integrated. The max option is often suitable. However, be careful if your drives have slightly different sizes. You might want to specify the desired size explicitly using a number followed by M, MB, G, GB, or T, TB. For example, size equals 5.4T. 5. Restarting the RAID array, activating the array. This step reassembles the array using the modified metadata. Make sure to replace /dev/sda1, /dev/sdb1, /dev/sdc1, and /dev/sdd1 with the actual devices that make up your array, identified in step 1. You can often use -scan to have mdadm find the devices, but specifying them explicitly is safer. 6. Reshaping the array, this takes a long time. This is the most time-consuming step. It's where the actual RAID 6 parity information is calculated and written to the drives. The system will be somewhat slow and unresponsive during this process. *RAID devices equals 4, this specifies the total number of data and parity devices in the array after the change. In this case, we are keeping the original 4 drives, so the number of devices remains the same. However, it is important that it matches the original RAID 5 array number of devices for a RAID 5 to RAID 6 transformation to work correctly. *backup file equals /root/raid_backup.img, this is highly recommended. MDAD can create a small backup file that contains critical metadata in case the reshape process fails. If it fails, you can use this backup file to revert the array back to its original RAID 5 state. Make sure there is enough space at the path to create a 100 MB file. Important notes on reshaping ***. Reshape speed * you can control the reshape speed using the /proc/sys/dev/raid/speed_limit_min and /proc/sys/dev/raid/speed_limit_max files. Lower values will make the reshape slower but reduce the impact on system performance. Higher values will speed up the reshape but may make the system less responsive. The defaults are usually a good starting point. To change these values temporarily. Potential issues during reshape ** power outages, hardware failures, or other system crashes during the reshape can corrupt the array. This is why a UPS and a robust system are so important. The backup file is critical in case of failure. Background process * the reshape process runs in the background. You can close your terminal after starting it. 7. Monitoring the reshape process ***. Monitor the progress of the reshape using cat/proc/mstat. The output will show something like this. Key information. Reshape equals 0.8%, 4898432/58537611792, this shows the percentage completed and the number of blocks processed. Finish equals 5999.2 minute, the estimated time remaining, this can fluctuate wildly. Speed equals 16384K/sec, the reshape speed. Another way to monitor the reshape process is. This will show similar information to /proc/mstat, including the progress and estimated completion time. 8. Verifying data integrity ***. After the reshape process is complete, the cat/proc/mstat output shows the reshape is 100% and no longer active. It is crucial to verify the data integrity. This is not guaranteed, even if the reshape completed successfully. File system check * run a file system check on the mounted RAID array. This will check for and attempt to repair any file system errors. Data comparison * compare a portion of the data on the RAID array with the data in your backup. Use diff for text files or CMP for binary files. If you have a large data set, consider using a checksumming tool, like MD5sum or SHA-256sum, to compare checksums of files between the RAID array and the backup. Application testing * if the RAID array hosts applications or databases, thoroughly test those applications to ensure they are functioning correctly and that data is being accessed and written correctly. Read/write tests * perform read and write operations on the array to further verify its health. Copy large files to and from the array and compare checksums. Example data comparison using diff, for text files. If diff returns no output, the files are identical. If there are differences, investigate and determine the cause. Example data comparison using CMP, for binary files. If CMP returns no output, the files are identical. If it reports a difference, it indicates a problem. Example using MD5 sum for checksum comparison asterisk. Troubleshooting asterisk. Asterisk reshape fails asterisk. If the reshape process fails, use the backup file to revert the array to its original RAID 5 configuration. Then, investigate the cause of the failure, example hardware issue, power outage, and address it before attempting the migration again. Consider increasing the speed limit_min if the reshape seems to be failing due to high I/O load. Asterisk data corruption asterisk. If you find data corruption after the reshape, restore from your backup. The point of the backup is to recover from such scenarios. Asterisk slow reshape asterisk. The reshape process can be slow. Ensure that your system is not heavily loaded with other tasks and that the drives are performing optimally. Check the smart status of your drives for any errors. Asterisk array fails to assemble asterisk. If the array fails to assemble after stopping and modifying it, double-check the device names and the UUID of the array. Ensure that all the devices are present and functional. Important considerations asterisk. Asterisk hardware RAID asterisk. The commands and procedures will be different for hardware RAID controllers. Consult the documentation for your specific controller. Hardware RAID controllers often have GUI-based interfaces or command line tools for managing RAID arrays. The principles remain the same, but the execution differs. Asterisk LVM, Logical Volume Manager. If you are using LVM on top of your RAID array, you will need to deactivate the logical volumes before unmounting the file system and stopping the RAID array. Activate them again after the reshape is complete. Asterisk drive compatibility asterisk. Ensure that all drives in the array are compatible with RAID 6. While this is generally not an issue with modern drives, older drives might have limitations. Conclusion asterisk. Migrating from RAID 5 to RAID 6 without data loss is a complex and potentially risky operation. Thorough planning, a robust backup strategy, and careful execution are essential. If you are not comfortable with the command line or have any doubts about your ability to perform this migration, seek professional assistance. Good luck, and remember to back up your data.